Today we're studying probability. We say that probability is defined as the measure of the intended outcome divided by the measure of all outcomes. And when I say measure, that could be like actually counting how many things happened. Or it can be length, area, volume, so that's where the geometry comes in. We're going to do a couple that we can just count right away. If you're rolling a die, what is the probability that you roll a 5? Well, if we're following this formula, we count the measure of event outcomes. This is the event that we want to happen, rolling a 5. How many ways are there to roll a 5? There is only one 5 on a die, so the top number is 1. And the measure of all outcomes, how many different numbers could come up? There are 6 different sides on a number cube, and so the probability of rolling a 5 is 1 out of 6. Imagine in your closet that you had 2 red polos and 3 white polos, and you were going to randomly choose a polo for the day. What is the probability that you would select a red polo? So this is the event that we're talking about, selecting red. And so the number of red polos would be your top number. And the number of all polos would be your bottom number. Looks like 2 plus 3 would be 5 polos total. So the probability you're going to grab a red one is 2 out of 5. This one looks a little more geometry-like because we're talking about length. These are parking spots, and a bird flies along a row of parked cars. It poops somewhere between points A and D. What is the probability that the poop landed between B and C? You know, like maybe you were the one that was parked right here. What are the chances that the poop landed there? So what we're going to do is we're going to find out the probability that the poop landed somewhere along segment BC. So what we're going to do is we're just going to take the length, because we're talking about a number line sort of look here. We're going to take the length of BC and compare it to, we know that the bird poops somewhere between A and D, so we're going to compare that to the total distance it could have been in. So out of all the places it could have gone from negative 15 to positive 10, what is that? A total of length of 25? What are the chances that it let loose between B and C? Well, that's the width of 10. So this is how we would use length to talk about probability. We could say that the probability is 10 out of 25. We could also reduce that to 2/5. What are some other ways we can rate probabilities? We can put them as decimals. 2/5 comes out to 0.4, like 4/10. Or some people like to write that as a percentage. That would be a 40% chance of pooping between points B and C. All of those would be fine answers for that probability. We're going a little two-dimensional on this one. A stray javelin lands in an area designated for the shot put. What is the probability it lands in the shaded region and not in the shot put circles? I hope it doesn't land in the circles. That's where the people are shot putting from. So I'm going to write this one as the probability that that javelin lands in the shaded area. And so what we're going to do is we're going to find, what do we compare? The number from the event. So on the top we'll do the area of the shaded. And on the bottom we always do all possible outcomes. In this case, that's the total area. It did say that it lands in the area designated for shot put. I'm assuming that that is that rectangle, the 10 by 14 rectangle. We know the javelin has landed in there, somewhere within those 14 times 10, somewhere within the 140 square feet. So that's our bottom number, 140 square feet of rectangle. Now, what are the chances that it missed the circles and it landed somewhere in the shaded area? Let's talk about how we would find that shaded area. We would just take the area of the rectangle and subtract off the area of the 2 circles, yeah? We already found the area of the rectangle is 14 times 10, so 140. And how about those circles? I know that circles are going to be an area of pi r squared, but I suppose I should find r. Do you guys know how big the radius is on these? I think it's less than 5, because if we went up 5 and down 5, that would actually span the entire 10 feet, right? Oh, but actually, since the circles touch the edges going this way, if we know that total length is 14, We could split that in half, so it's going to be a 7 and a 7, which means all of those radii are going to be 3.5s. So it's good that those circles were nestled right in there because I knew I could use that 14 to determine the radius. So back to that shaded area, we're talking 140 minus 2 times pi 3.5 squared, which would be 140 minus, and in terms of pi, let's just leave the pi out for a second and just multiply the 2 times the 3.5 squared, because that's 24.5. So whatever 24.5 times pi is would be the area of the two circles. And you know I don't like you to round until the final answer, so I think I'm just going to leave it like that. We can't combine those because they're not really like terms. So the top number is going to be whatever 140 minus 24.5 pi equals. Now when you type all this in to find our final area, it's fine to round on our final answer. Make sure you use parentheses around the top of that. Or some of you are used to pushing enter and then dividing that answer by 140. So for area of shaded over total area, I am getting 0.45022, and I suppose I would probably say that that's 45%, but just watch the problem and see if they care how you're giving your final answer. There's a 45% chance that even though the javelin landed in the rectangle, it missed those circles and landed in the shaded area. Here's another 2D one. It's going to be an area thing. After pouring a triangular concrete patio in his backyard, a man finds out that there's buried treasure somewhere in the yard. Doesn't that always happen after you pour the concrete patio? What's the probability that the treasure's under the concrete? That'd be some terrible luck. So the probability basically that the treasure's under the concrete would be the probability that it lands somewhere in that shaded area. So again, we're just going to find the area of the shaded over the total area. Sometimes I think the total area is easier. Maybe not on this one though, because it doesn't actually give me the whole height. I guess that's probably like more the length of his backyard. I know the 11 at the bottom, which translates to 11 up here as well. Oh, but wait, these are congruent, aren't they? Must be a square backyard. So every side is 11, which means that 8, that would just leave me with an extra, what, 3 right here? Okay, so the total area is just 11 by 11. 11 times 11 is 121 square meters. And now we just need the area of that shaded triangle. What dimensions do we know? I guess I just figured out the height of it, didn't I? Would it help if you looked at this upside down for a second? The base is 11 and the height is 3. Even if it is upside down, we can use 11 as the base and 3 as the height. So the area of our shaded part would be, since it's a triangle, 1/2 base times height. And there's no funky pi or anything in there, so it'd be fine to figure that out right away because it comes out to 16.5 even divided by 121, and our probability is about 0.13636363. Yeah, it's repeating. Just the 3 and the 6 seem to be repeating. We could leave our probability as a fraction. We could write our probability as a decimal. I tend to be more of a percent girl, so I think I'm going to go 13 point. Now, if that was 0.136363, and I wanted to round it to like 13 point something percent, what would my next number be? There's the 13 point. Should I round that 6 up to a 7 or keep it at a 6? That 3 behind it tells me I'm going to leave it at a 6. So if I'm rounding this, it's going to be a 13.6% probability that that treasure is under your new patio. Might be worth digging it up though, you never know. Here's one that's sort of a number line idea again, because we're talking about times. You attended a soccer game that went from 5 to 7:30. There was only 1 goal scored the entire game. At 6:10, you went to the concession stand for 10 minutes. What is the probability that you missed the goal? It's all about that bad luck today. So the probability that the event missing the goal happened. you missed the one time they scored would be, well, you would have missed it if it happened during the time you were at concessions. But otherwise, you were there for the whole game. And we know that you were only at concessions for 10 minutes. And how long did the whole deal last? It went from 5 o'clock to 7:30. That's 2.5 hours, right? And I suppose since the 10 is in minutes, we better put 2.5 hours into minutes. So 60 plus 60 plus 30, 150 minutes in 2.5 hours. So the probability that you had such bad luck that you missed the goal is 10 out of 150, which reduces to a 1 in 15 chance that you missed it. If you prefer your probability as a decimal, that'd be 0.06 repeating. And if you're a percent kind of kid, 0.066666. If I wanted to round it to, I suppose I would say 6 point something percent. I usually like to go one decimal there. So here's the 6%. Would I round that up to a 7 or would I leave it a 6? All depends on what's behind him, and that 6 right there makes him worthy of being bumped up, so that would be about a 6.7% probability that you missed the only goal during the whole game. That'll teach you to go get snacks. So why are we learning about probability again in geometry? Because a lot of the times you're going to use lengths and areas and maybe even volumes to measure probability. And they call that geometric probability.